Okay dah. Already start recording. Okay. Okay. Assalamualaikum warahmatullahi wabarakatuh. Uh, Nafiz. So like we planned today, I am going to teach you some of my topics in my course, which is computing. The topic I will teach you today is just easy one, not the hard one. That is logic gate. Uh, as you know, we already learned this in our form 5, so it will be just as easy like SPM. Maybe a little harder. Just some we will add some of other topics in this logic circuit, but it will still be easy. Not hard, just easy. Okay, now I will present to you the slides. Okay, wait a minute. Okay.
Yes.
Okay, can you see my slide now? Yeah, can you see? Okay. Okay, I will start now. Okay. Logic gates. Okay, in this topic, the lesson we will learn is at the end of the lesson, we will able to learn to understand Boolean algebra, uh, Boolean operators, and axiom and theorems. For axiom and theorems, there actually we need to memorize the theorem, the law of Boolean algebra. So I guess I will not really teach you the axiom and theorem. You need to understand by yourself. But for Boolean algebra and Boolean operators, I will teach you really detail about this because it's the same as what we study in SPM for physics. They're the same. Okay. For Boolean algebra, the digital computer is based on Boolean algebra. George Boole, a mathematician, described a method we make logical decision based on true or false circumstance. As you see on the diagram on the right side, zero means false, off, low, no, open switch. While for one, for the digit one means true, on, high, yes, close switch. Uh, the system of using symbols and operators to describe this decision is called Boolean algebra. The purpose of this logical expression is to describe the relationship between a logic circuit's output and its inputs, the circumstances. Before we want to make a logic circuit, we first need to understand what is Boolean algebra and Boolean expression, and also Boolean operation. And then for Boolean operation, we have three, which is and, or not. Uh, there are many symbol and equation, just like the slide. You see, the symbol is here, here, but the common one that we use in our exam is this, the one that I draw. This is the one of the common that we use in our exam. But there are also many other symbols that can be used. For n, we can see here dot and for all we can see here. For not, we can see here. So after we know the Boolean operators, the Boolean operation and Boolean algebra, we now can make a truth table. A truth table describes the relationship between the input and output of logic circuit. It shows the output state for every possible combination of input states. A truth table also a way to show the function of a logic gate. The symbol 0, which means false, and 1, which means true, are used in truth table. For logic circuit with n inputs, there are two entries in the truth table. The number of entries correspond to the number of input. This means that if the logic circuit, there are logic circuit that have one input, two input, three input, and more. But for our syllabus, we will just learn maximum of three input. For if we have one input, we must put the input in the end. So that where we will put, okay, so example, we have one input. So the output will be 2. If we have two input, we will have the 2 power of 2 equal to 4 output. If we have 3 input, to the power of 3, we will have 8 output. The output here means the row. I will show you example here. Okay, you can see here. Uh, this is the input A, B, and C. As you know, there are three inputs, which means that 2 to the power of 3 equals to 8. 8 input or means 8 row. Yeah, one, two, three, 4, 5, 6, 7, 8. 8 row. We must have 8 row. If we don't have 8 row, the truth table will be wrong, not correct. And as you can see here, A, B, C plus A, not B, and the symbol times here means that it is N, and the symbol plus here means that it is OR. And this is algebra or Boolean algebra. Okay, back to the slide. Not operation. Like the symbol earlier, the symbol here is one of the common symbol that we use for not operation, not symbol. Which mean it is uh, it will inverse the operation. Which as example, the operation is 1 is true, but when we have not in front of it, it will inverse the of operation becoming false. Like true becoming false. If false, it becomes true. The operation. We can you can see here the A operation is false, which is 0. After we put the not on the A, it becomes 1. It inverse becoming 1, true, and 1 becoming 0. And N operation is only happens uh, uh, only the result of N operation is true if and only if both input operands are true. You can see the example here. We put A and B, and the output is AB or C. So both of them are 0. So the output is 0. At B, the input is 1, while A is 0, the output is 0. While A, the input is 1, B is 0, the output is 0. And then when the both of them is 1, is true, the output then is 1. This is the AND gate. But for OR gate, OR operation, you can it will it will result in the output to become true if either one of them are true. You can see the example here. Even though A is 0 while B is 1, but the output is 1. And A is 1 while B is 0, the output is 1. So it's different from AND operation. Okay, uh, just like I show here, truth table for two input, two input, two input, and two input. What if we add another input, becoming three input? The situation will become different. So like this here, it is the different concept for N. like we say, and we need, in order to have the true output, we need to have all the input in true. The two, both of the input in true. It's the same for the three input. We must have three input the same, true. Three input are true, and then we can have the output is true. If we don't have all the same, all the input in true, we cannot have the output in true. Like this example right here. They all is zero. They all are false because only two or one or none of them is true. Okay. So no gates and NAND gates. No and NAND gates are widely used in digital circuits, combine basic AND or and NOT operation. The NOR gate is an inverted OR gate. The NAND gate is an inverted AND gate. Yes. The NOR gate is an inverted OR gate because uh, OR gate plus with NOT gate, it becoming NOR gate. An inverted and AND gate plus with uh, not gate becoming non gates. Here are the example of the diagram of the NOR gate. Here we have OR gate, OR gate, and then we have the inverted, the NOT gate becoming. So the Boolean algebra is A plus B. The input is A and B. A plus B because it is OR gate. We must plus it, and then we inverse it. The symbol of NOT, like and A times B because the gate is B, A because the gate is N, and then we inverse it. This is the example of NAND gates. As an example of example of an AND gate, as an example of the use of AND gate, consider a typical microwave. The microwave starts working when the start button is pressed and the door is closed. Let assign to represent start button, B to represent door, and X can represent the microwave. The truth table below shows what happens when two logic input A and B are combined using the AND operation to produce output X. This is some of question
Muhamad, tidak.
that that they give. They will not give direct question uh they give direct Boolean algebra. They will give long question. Microwave, typical microwave that use that you combine an operation. And from the question, you must first the first step is we must draw the truth table. And after we draw the truth table, that we can draw the logic circuit. There are some of example, an example of truth table question. Here are some of also some is question. For question one, they give us the logic circuit, the draw of logic circuit, and then they ask us to write the expression for the output y. Here, output y. What is the output of the out of the y? So we need to first uh, write the expression for the output y, and then we can draw the truth table because we want to draw the truth table based on the uh, bull, bull, Boolean expression or Boolean algebra from output y. So based on logic circuit, we can we can we, we we find the Boolean expression, which is A plus B, A or B, if not, and then times, which is N, B or C. A and B are here, and then B and C. And then A, B, and B, C, N. They will meet together. From the circuit, we can make an algebra expression. And some of the question also give us the expression, the Boolean expression or Boolean algebra. And then from the Boolean algebra, they ask us to draw a logic circuit. So based on the Boolean expression they give us, we can make truth table. We can make truth table, or we can just draw directly. Don't need to make truth table. If they ask us to draw, just draw directly. If they ask us to do a truth table, do a truth table. Boolean algebra. Electrical switches. Okay, start. So basically, that's all that I want to teach you for axiom and theorems. These are law of Boolean algebra, which is consists of many things: commutative, identity, annulment, distributive, complement, idempotent, absorption. This actually we need to memorize it. So I think this may take a long time to present. So I think that's all for our discussion. Thank you, Nafiz, for being here with me.
Mm. Okay, welcome.
Stop. Okay.